Hello, juniors. Today we're gonna see the last new topic about this chapter about linear functions and quadratic functions. We're gonna see some real life applications of quadratic functions. Okay, so we're gonna solve three examples that are completely applicable to real life situations. So pay attention to these problems that we're gonna solve now. So, applications of quadratics. The objective for the class is to apply quadratic functions to solve real-life problems. After this class, we're gonna do some practice exercises with real IB exercises about this topic, and then we're probably gonna have a short formative test before moving on into a new topic. So, first example. It says, a farmer wishes to enclose a rectangular garden with 100 meters of fencing. Okay, so two things here. We have a rectangular garden. Let's draw the rectangular garden. Something like this. And we know that we have in total 100 meters of fencing, right? So we cannot use more than 100 meters, but if we want, we could use less than 100 meters. But later on in part C, we're asked to maximize the area. If we want to maximize the area, we should use all of the fencing we have, right? So we need to use the 100 meters. So part A, it says, if the garden is x meters wide, find the length and the area of the garden in terms of x. Okay, so x meters wide. Wide would be this side over here. If that side is x, then this one should also be x, right? Then find the length of the area and the area of the garden in terms of x. So we're gonna call the length, we can call it y, okay? Y and y. So we know that if you're gonna use all the 100 meters of fencing, we know that 100 would be the perimeter of this rectangle over here. So we can write this as 100 equals the perimeter, which is the addition of all the sides, which is y plus x plus y plus x, right? So this is the same as saying 2y plus 2x. And it says that we want to find the length in terms of x, right? So if we want to find the length in terms of x, we need to solve for y or leave the y alone, right? So this would be equal to 100 minus 2x is equal to 2y. So then if I divide by 2 both sides, divided by 2, and all of this divided by 2, this would be the same as saying 50 minus x equals y. So this would be the length of the rectangle in terms of x, okay? Wait. There you go. So then we want to find the area of the garden in terms of x. To calculate the area of a rectangle, remember, I'm gonna do it here. The area of a rectangle is always length times width. So in this case, it's y times x, length times width. We already have y written in terms of x. So we can write this equation as area equals 50 minus x times x, right? So if we simplify this expression, this would be, let me do that here, area equals 50x minus x squared. So this would be the area of this rectangle written in terms of x, okay? So that's it for part A. Then we're gonna move on with part B. I'm gonna continue down here. It says, find the width of the garden if the area, with an area of 525 meters squared. So we're given the value of the area, so we want to find the width, which is x, right? So 525 is equal to 50x minus x squared. And this would be a quadratic equation that we need to solve, right? If I take all of the terms to this side, we will have x squared minus 50x plus 525 equals 0. And then we can solve this using any of the tools we have. We can do by factorization, we could do by completing the square, we could do by applying the quadratic formula, or using the GDC. Okay, in order to save some time, I'm gonna solve this using GDC. You already know how to do this, so I'm not gonna show you this anymore. You go to menu, equation, and then you put polynomial degree 2, right? Then you plug in the coefficients, which are 1, -50, and 525, and you get two values of x. The first one being 35. We're talking in meters, right? So this is meters. Or another possible value of x would be 15 meters. Both of these are valid because both numbers are positive, right? So it says find the width of the garden with an area of 525. Okay. So both of these results are valid, as I told you, right? And well, if you stay with this answer, you have a garden that has a greater width than its length, right? But for this particular drawing I did here, the right answer would be to pick this value of x, as this would be the width and this would be the length. Okay, that's why we're getting two values of x. One corresponds to the width and the other corresponds to the length. Okay, so I'm gonna stay with both results for now because both of them are valid. So we're gonna see then part C. It says find the maximum area the garden can have. If you take a look at the equation of the area, let me write that here. I'm gonna write that area equals, and I'm gonna write on purpose the x squared in front, just for you to analyze. What type of quadratic function is this? If you see, this has a negative in front of the x squared, so we're talking about, if I do a quick sketch of the situation, we're talking about a parabola that opens downward, right? Something maybe like this. I'm just doing a sketch, okay? It opens downward because this value is negative. That means that there's one value over here, which is the vertex, which produces a maximum area. You see that the area, this a over here, is the same as our y when we're graphing. So we could say that this axis is actually the area of the garden, and here we have the width, or the width of the rectangle, right? So if we calculate the vertex of this parabola, we will be finding the maximum possible area of this garden. Okay, so we need to calculate the vertex. If you remember, if we have this equation over here, how can we calculate the vertex? We could calculate it by identifying the axis of symmetry first. If you remember, the axis of symmetry can be calculated by doing minus b over 2a, which would also be the x coordinate of the vertex. So this would be equal to, in this case, b is 50, so negative 50, over 2 times negative 1, which is a, and this gives us 50 divided by 2, that's 25. So that this 25 over here would be the width necessary in order to have the maximum area, right? And if we want to calculate what is the value of the maximum area, I can plug in these values of x into the corresponding equation, and I'll find the maximum area. So the maximum area would be equal to negative 25 squared plus 50 times 25. And if you solve this using calculator, we should get a value greater than 525 because we're talking about a maximum value. So let's see, this is negative 25 squared plus 50 times 25, and this gives us 625 meters squared. And I can assure you that this is the maximum possible value that you could obtain. There's no other possibility given this condition of having only 100 meters of fencing, that would produce an area greater than this. So in order to build a garden with a maximum area, you would see that if the value of x is 25, that means this is 25, this is 25. If we add both, we have 50. That means that y should also be 25, right? 25, 25, and we'll get the other 50. So that means that the garden, in order to maximize its area, should have a square shape. Okay? So that is the shape that maximizes the area in this particular case. Okay, so you see how this is a very practical application of quadratic functions, right? You can determine how much area, or you can maximize, in this case, the area of a particular garden or whatever you're building in order to buy or depending on the amount of fencing you have, or the amount of cable you have, or whatever. Okay, so that's a first important application of quadratics, being able to maximize or minimize, depending on what you're trying to obtain, a specific variable. Okay, now let's see another example. It says the height of a ball t seconds after it is thrown is modeled by the function height equals 24t, where t is time, minus 4.9 t squared plus 1, where h is the height of the ball in meters and t is the time in seconds. Okay, so this is a very common example of quadratic equations. Parabolic motion when we throw a ball, right? You normally study this in physics. Okay, so let's go to a problem. It says find the maximum height reached by the ball. So you see that we have the equation here. H, the height, equals 24t minus 4.9 t squared plus 1, right? Height with respect to time. So if we want to find the maximum height, once again, let me rearrange this formula in order to see it as a quadratic function. Minus 4.9 t squared plus 24t plus 1. So you see that we're getting, this is the general form of a quadratic equation, and once again, the value of a is a negative number. So if we make a quick sketch of this, something like this. Remember, this is only a sketch just to see what's happening. So in this case, our x-axis would be time and the y-axis would be height, right? H. So as this value is negative, the parabola should once again open downwards, right? So this would look something like this. So yes, this is the, actually, because we're talking about time and height, we should begin our time at 0, right? And you see that if we replace time with 0, we're gonna get the initial height of the object, which would be 1, which is the y-intercept, right? So if we want to make kind of a more precise sketch, we could say that the initial height is 1. So the parabolic motion would start like this, and then the ball will fall down, right, until it reaches ground. But as always, we will have a vertex, right, which would correspond to a maximum because this parabola opens downward. So this vertex over here would be the maximum height reached by the ball. So we need to calculate that vertex. To calculate the vertex, we're going to do the same thing we did in the last exercise. We're going to calculate the axis of symmetry first, which is negative b over 2a. If we plug in the values, in this case it's negative 24 over 2 times negative 4.9. You can calculate this using calculator, and you will get a value of x which equals, let me see, this is negative 24 over 2 times negative 4.9. This gives us 2.45. Remember that x in this case, let me change this. We're talking about t, right? Time is our x in this case. So in 2.45 seconds, the ball would reach its maximum height. but we want to calculate what is that maximum height. So in order to calculate the maximum height, we're going to plug in this time into our equation of height with respect to time. So we plug in here, height equals negative 4.9 t squared times 2.45 squared plus 24 times 2.45 plus 1. So then we can obtain the value of h, the height, which would be, let me do that, negative 4.9 times 2.45 squared plus 24 times 2.45 plus 1. This gives us 30.4 meters. So this would be the maximum height of our ball in this case. Okay, so just to clarify, this point is 2.45 and this value here would be 30.4. Remember that time in this case is measured in seconds and height is measured in meters. Okay, then for part B, let me separate this here. For part B, it says, for what length of time will the ball be higher than 20 meters? Okay, so if you look at this situation over here, we know that the maximum height is 30.4, okay? So 20 meters should be a value somewhere around here, maybe, right? Remember, this is a sketch. So it's a value less than the maximum. So you see that our object crosses 20 meters twice, right? Once when it is going up and once when it is falling to the ground, okay? So if we read the question once again, it says, for what length of time will the ball be higher than 20 meters? Okay, so we need to find this interval of time in which the ball first reaches 20 meters and then time passes until it reaches 20 meters again when falling, right? So what we need to do is basically calculate those two times where the ball would reach 20 meters. So 20 meters is our data, so we're going to use height as 20 and we're going to plug in that into our equation. We're going to have 20 equals negative 4.9 t squared. We're going to find the value of t plus 24t plus 1. So if we organize this would be 0 equals negative 4.9 t squared plus 24t minus 19. If we use our calculator in order to save time, using calculator, we're gonna go to a polynomial, right? You already know how to do this. So we go to menu, equation, polynomial, degree 2, and you plug in the coefficients, negative 4.9, 24, and negative 19. If you calculate the two values, we're going to get one value of t, which is 0.993 seconds, and another value of t, which is also positive, that gives us 3.905 seconds, which, if you see in the graph, sounds very logical, right? The first time the object reaches 20 meters would be at 0.993 seconds, and the second time it reaches 20 meters would be at 3.905 seconds. Okay, so it's congruent with the situation. So the question is, for what length of time will the ball be higher than 20 meters? So from this first intersection to this second intersection, how much time has passed? We need to subtract this value minus this value in order to find that time interval. Okay, so basically the change in time during those two periods of time would be 3.905 minus 0.905. 0.993. And then we calculate that interval of time, which would give us 3.905 minus 0.993, and this is 2.91 seconds. That is the interval of time from the first time it reaches 20 meters to the second time it reaches 20 meters. Okay, so I hope this is clear enough. Okay, so let's see the last example, which involves an economic application of quadratic functions. It says a bakery sells apple pies for $12 each and sells an average of 40 apple pies per day. Okay, then it says the owner estimates that for each $0.50 increase in price, the average sale will decrease by 1 pie per day. Okay, so there's one thing that you should remember when we talk about these types of problems, which is that the revenue would be like the income of my sales. So the revenue, my ganancias would be that. Revenue is always equal to the price of the product I'm selling times the quantity of products I'm selling. And that's pretty logical, right? If I sell, let's say candies, if I sell 10 candies at 5,000 guaraníes each, then my revenue would be 50,000 guaraníes, right? 5,000 guaraníes times 10. Okay, so that's revenue, which in Spanish is called ganancia. Okay, so it says suppose that there has been X increases of $0.50 in the price of an apple pie above the initial price of $12. So for part A, write down an expression for the price P of an apple pie after X increases of $0.50 above the initial price. Okay, so the equation for the price would basically be $12, which is the initial price, plus 0.50, which is the little increase I'm giving to the price, after X increases, it says. So 0.50 times X. We don't know how many increases we're applying, but the general formula, in case we do one increase, X would be 1. In case we do 2 increases, X would be 2, and so on, okay? So this would be the general formula to find the price after X given increases of $0.50, right? Okay, so that's it for part A. Then for part B, it says, write down the number of apple pies sold per day in terms of X. Remember that for each increase that we do, the average sales decrease. We're selling less when we increase price, which is completely logical, right? Decrease by 1 pie per day. That means that if I increase 1 times 0.50, that is if X is 1, I'm gonna sell 1 pie less that day. Okay, so for part B, write down the number of apple pies sold per day in terms of X. So we can write this as quantity, right? Okay, I can call it Q equals I normally sell 40, but for each increase in X, I'm gonna sell X pies less, so minus X. Okay, if I increase my price 1 time, then I will sell 39 pies only, right? 40 minus 1. Okay, so this would be the equation for the quantity. It decreases as I increase my price. Okay, part C. Find a function that gives the estimated revenue from apple pies sales in terms of X. Okay, so we already know that the revenue equals the price times the quantity, which is what we just talked about at the beginning of this problem. So if I plug in both equations that I wrote in part A and part B, sorry, the other way around, price P and quantity Q, then the revenue equation would be equal to 12 plus 0.50x times quantity, which is 40 minus x, okay? And if we simplify this expression, this would be revenue equals 12 times 40, that's 480 minus 12x plus 20x and minus 0.5x squared. And if we keep on simplifying this, we'll get the equation, which would be, let me write this term first, negative 0.5x squared plus 8x plus 480. So you see that once again we're getting a quadratic equation out of this problem, okay? So this would be the function that gives the estimated revenue from apple pie sales in terms of x. Once again, you see that this quadratic equation has a negative coefficient in front of the x squared. That means that the parabola would open downwards. That means that I could find a maximum value for the revenue, right? If I do a quick sketch of this situation, in this case, we're gonna have revenue with respect to x, which is the number of pies. So I'm gonna write x, which is pies sold, and in the y-axis we're gonna have revenue, which is dollars for us, right? So this is a quadratic equation that opens downward, so it would look, our y-intercept is 480, so maybe we could do 480 somewhere around here. That means that if we sell 0 pies, we should have a revenue of $480, which in this case doesn't sound very logical, right? So the y-intercept does not have a real interpretation in this case. But the parabola should look something like this. Opens downward, so we're going to have this. We're going to have a maximum value, which implies a maximum revenue, which is the point that interests us the most. So let's see. For part D, I'm going to do that here. It says, use the revenue function to find the sale price the bakery owner should charge to maximize the revenue from the apple sales. So we need to find this maximum point over here. In order to find that maximum point, we're going to apply the formula, the axis of symmetry first, which is x equals minus b over 2a once again. So the value of b is 8. Then we have over 2 times a, where a is negative 0.5. And if we solve this, we're going to get x equals, this is positive 8, right? 2 times, yes, positive 8. That means that I need to sell only 8 pies. So is that okay? Let's see. So 8 pies. We're talking about pies in this case. I think I'm doing this correctly. Let me check. 8 divided by 2 times 0.5. Yes, that's 8. Okay, so if this is the amount of pies that I need to sell, what would be the revenue? The revenue, to calculate the revenue, we're going to plug in the value of x into this equation over here, and we would have negative 0.5 times 8 squared plus 8 times 8 again plus 480. Okay. Sorry, the value of x is not the number of pies, it's the number, let me erase this. Then we're gonna analyze what's the value of x. I'm gonna erase this. Okay, so the revenue is, let's calculate this using calculator, negative 0.5 times 8 squared plus 8 times 8 plus 480. This gives us a revenue of $512. And to find the sale price, so use the revenue function to find the sale price the bakery owner, I need to find the sale price. So we don't need to calculate this maximum revenue point, but since we already calculated, we're gonna leave it there. But we want to calculate the price. Okay, we already have the value of x that produces the maximum value over here, but now we need to calculate what that price would be. So price, if I plug in into this equation, would be 12 plus 0.550 times x, which is 8. This would give us the price, which is 12 plus 0.5 times 8. This gives us $16. So we should actually sell $4 more than the price that this person was already selling, right? So this is the optimal price in order to have the maximum revenue possible, okay? And if we want to calculate how many pies we need to do, we should calculate Q, which would be 40 minus X, where X is 8. So the ideal quantity of pies would be 32 pies. Instead of 40 pies, which is what we were initially doing, okay? So that's it. We were asked to find the sale price, and we found it, which is 16. So that's it for today's class, juniors. I hope this is clear enough for you. If not, please let me know, and we will clear the doubts in the live sessions. See you.